good evening, good morning. Well, I think we can start now. I hope I'm audible, clear and loud to everyone. Guys, if you can confirm, that will help. So thanks for joining. I warm welcome everyone, each of you, to join this webinar. So I can see a good amount of people who are really excited and learn something about machine learning. So I value your time and I ensure that you will learn something very basic and fundamentals about machine learning in this webinar. Okay. So my name is Ganesh Bhure, and I will be your facilitator for this, this webinar and training at Cognixia. So I'm a trainer for last couple of years with Cognixia, and as a whole, I have 16 years, corporate experience. I worked as a software developer, in various corporates earlier, and in my last role, I was a solution architect at Tata Group of companies. So and then, I have been into training for more than a decade now. It's been 11 years to be specific. I'm into training. I generally impart training on technology, right? It's a technical area where I do work on Python, data science, machine learning, artificial intelligence. So these are some of the areas where I do research. I do train and I do work on a couple of projects in my own company. Okay. So this is a brief background. I have been into corporate training. I have been into retail. I've been with the Cognixia and many different groups work on training assignments globally, right? And for this particular webinar, we have arranged to give you the idea, the overview about how machine learning can help you improve your business performance, improve your career aspirations, and make something valuable contribution into your projects, be it whatever domain you are in. Okay, so I'm really super excited, guys, for the machine learning because this is the area where I do a lot these days, right? And definitely I will ensure that you will learn something out of this discussion. Okay, so I see a lot of excitement from the group as well, a lot of questions I can see. So don't hesitate, put your questions in the chat box or the questions box. There's a questions tab on the tool. Go to webinar tool. So feel free to put your questions, all the technical questions, whatever comes in your mind. I will try to answer as many as I can, but I keep that window for answering towards end of this discussion, right? We will start with the flow where what are things I have to cover, I want to cover as part of this webinar. So we will cover that, and then later on I'll take your questions, right? So don't hesitate, put your questions, and I will definitely try to answer each of your question. Okay. First, let me, before deep dive into the topic, I would like to introduce a little bit about the company, right, with whom we are, we are associated with, the Cognixia, right? They are into professional training for last many years, and they have been doing this fantastic work globally, right? They have more than 150,000 professionals trained. They are authorized training partner for Red Hat, ISC Square, Microsoft partner, Automation Anywhere, right? And they have delivered fantastic training for many countries globally, right? More than 45 countries they are working in, right? There are 7,000 industry veterans as instructors they have globally, right? And 450 plus customers. Okay, so they have list of awards. If we want to go through, right, you can probably read some of these. ISO certified company, right? So Asian Training and Leadership Award, Dubai, right? So Cognixia is also awarded training company for the year 2018, right? So and there are so many, actually list is bigger, so I want to jump onto the topic. So there are a couple of things. Center of excellence, machine learning and AI. Okay, that's where we are talking today, but they are more into machine learning, AI, and microservices, RPA, robotic process automation, IoT, Internet of Things, cybersecurity, cloud computing, DevOps plus, right, and BI technology. So these are some of the areas where Cognixia has been doing fantastic work, and they have they have been doing globally with the top-notch trainer pool they have. Okay. Today, we will be focusing more onto machine learning, right? I know you guys are super excited for machine learning, what it is, how it is, and many of you might be knowing some basics, right? It could be kind of revision for you, but there will be definitely few things you will take out of this discussion. And those who are completely new, okay, to machine learning, right? So you will provide, definitely will. I'll try to match your pace as well. So we'll go through the basics. We understand the foundational principles behind machine learning, what machine learning is, how it works, and some of the applications in the industry, what is going to be the future for every industry which I'm talking about. So that perhaps will help you to plan your career, right? You can probably think about boosting your career responsibilities, be it in your working, whether you're working in a current organization or if you're looking outside your organization, right? So you can think about boosting your career path. This learning will take you, to the next level for sure, right? And definitely the readiness, where you can think about how you can grab better opportunities wherever you're working currently, right? So that's the whole idea, and definitely this helps to improve business performance, right? That's the topic I know I will be explaining you how this is going to help any business, right? So there are many businesses, they are facing challenges, and how machine learning, analytics, and artificial intelligence helps businesses to boost and to improve on the performance as a whole. Okay, agenda for the day. I would like to introduce you what machine learning is, right? How how it works basically in the mathematical space, and why we need machine learning, right? And the core part of machine learning are the idea how we have such a complex algorithms works to make some predictions without having any experience is are not possible, and that's where data comes in, right? We have more data, we have growth potential there, right? So definitely I would like to highlight a little bit with the data, what data is and how you will see that data is you can leverage the data to build such a complex system where you can think about getting a possibility of future predictions, forecasting, and different techniques to basically enhance or accelerate your business in terms of new revenue models or in terms of your customer delight or satisfaction, right? Or the better experience to your customers. So that's what the whole idea is, machine learning and AI brings onto the table, right? There are types of machine learnings. One should definitely know this, how machine learns, what are the different types of machine learning, and then we will also deep dive a little bit on the AI part, right? So how machine learning plays crucial role in AI and what is the difference. Okay, so in this webinar, I'm going to take 55 minutes to 1 hour, right? And later on, we will have 15 to 20 minutes for questions and answers, right? So I'll take maximum questions possible, right? I can see still questions are flowing in. Now, after machine learning, after types of machine learnings, one of the most important thing is what are tools and technologies we need to know. Okay, that's a very obvious question. A lot of people get in their minds, right? So what you need to learn, do you have a technical background, do you need a lot of technical or computer science knowledge, right? What you exactly need, right? What, how Python helps in machine learning, and what are the tools available in Python that you can leverage and develop some of the very interesting algorithms to solve real world problems. Okay, so those tools, you don't need to be expert in computer science, but I'll be honest, you need to know computer science, right? That means you can learn things, especially the Python like programming language, which is quite simple and easy to learn, and yet it is so powerful that it can solve so many complex problems for you. Okay, then there's exploratory data analysis. We would not be able to spend a lot of time here, but I still show you the idea behind exploring the data, right? What we do, why we need to do some kind of a pre-processing, and for that we need to explore the data. Then we have to process it in order to make your data ready for machine to learn out of it, right? So that means the statistical algorithm needs to learn from the data, and that data needs to be in the numerical format, right? So for that reason, we have to do some statistical analysis and pre-processing, right, in order to get that data where your machine learning algorithm can be applied, right? And a case study where I will show you how to create a machine learning model, right, in a very simple way. I will try to put 10 minutes of time on writing that code, okay, piece of code, which will help you visualize how we can write some code, some Python stuff to make some predictions. Okay, so that's the idea. Before we jump onto more details, let's try and understand what is machine learning, right? And I hope many of you must have read or did research and probably have learned out of some material or some books, right? Yes, it is a simple simple definition which I tried to put, and everyone can probably relate, right? So machine learning is no different than the AI, right? It's a subset of artificial intelligence. So in short, machine learning is used to automate few things which we want to actually leverage into artificial intelligence. Okay, so machine learning is a subset of AI which is used to make some predictions for future, right, where the statistical analysis can be done, right? So you can apply statistical analysis and make some predictions out of the data which you have, right? So in short, machine learning is the process of making machines learn. It's a very similar to how a kid learn, right? How a baby learns, right? Baby learns by looking at the things, by looking at the experience, right? A similar way, we want machines to learn basis on the data what you have, and that is the that plays as an experience for the machine, right? So in short, we have a historical data, and we will try to figure out the relationship between independent variables and dependent variables, so that we can have that relationship in order to bring the influence out of your new data which you are getting, and that new data will be having the prediction basis on the historical relationship what we have. Okay, it's a very simple thing, but once you understand a little bit basics around the maths, how it works, right, how the algorithms are developed in statistics, right, probably it will make more sense. Okay, so that's how we make machines. So as I said, it's a subset of AI. So AI is nothing but a creating set of rules to perform any intellectual task the way human works, right? So it is like mimicking the human behavior, right? And machine learning is one part of it which automatically figures out those rules, okay, by looking at the data which is there, that is a historical data, guys, right? And there is a more to that, right? So once you learn machine learning, there is something called deep learning, again a part of machine learning, right, where the process of learning differs, but the principles are same. We are trying to make machines learn things out of your data, right? So the principle changes there basis on the neural neurons, the teeny neurons which is available in the human brain, right? And that's the process, and that is called artificial neural network, right? That's the next step one should learn beyond machine learning, but we have some coverage of the same in this course as well. Okay, let's understand what drives majorly into the machine learning and AI. What makes this thing to be a so popular thing, right? So how AI and machine learning helps us to achieve a true digital transformation, what we see today in the industries, right? So this is amazing feat what we have seen, right? So if you think about 150 years ago, when electricity was not there, and later on it has transformed the way industries worked, right? Similar transformation happened 20, 40 years ago, right, when internet came in. So you guys, we are at the stage where now AI is and the machine learning is at the edge where we can see the next generation or next revolution in the industries, that is a true digital transformation, right? Every businesses are looking at, right? That intelligence we can build onto the machines, right, through the statistics and some of the basic stuff what we have in this particular course, we used for. Okay, and this can be used to optimize your business process, minimize the cost, or maximize the revenues, or maximize the user experience, customer experience, and so on. Okay, so we will cover some of the basic points around this, but for this we need to know why there is a sudden demand in machine learning now, right? So one of the reason is data. Okay, one of the reason is data, right? If you see, every mobile has so many apps today, right? So everyone, even kids, started their own world of uh, apps they have, right? They generate huge amount of data, right? We generate, they are social, there are, everyone is now having one or the other kind of our lives are dependent on these apps, right? So there's a potential growth, there is exponential growth in the data we have observed in last few years, right? Especially last 5 to 10 years is what we see. There's exponential growth in the data, right? And we want to learn the facts around the data, and that is where the machine learning and the statistics comes in, right? There's a huge data. If you see the growth in this particular slide, right? So today it is somewhere around 45 zettabytes of data available. Okay, that's huge, guys, right? It is like 45 trillion GB data, right? Trust me, if you want to download this, it will take 200 million years to download if we have a internet speed of 40 mbps. That's a huge data, right? And a lot of companies have data and nobody knows what to do with that. Okay, that's where a machine learning engineer, a data scientist, or AI engineer, right? So those people can actually bring some sense out of it, right? And that's where companies are heavily invested, right? They are investing, right? Because data has that future potential, and there is a huge data explosion yet to happen, I would say, because of 5G coming in, because of IoT, sensors, home broadband, or you might have heard about autonomous car, right? Even those machines generates a lot of data, and data is needs to be processed through such complex algorithms, right? In the machine learning. Okay, so data is the new oil, right? So we have companies, the giants who have a lot of data, and how these companies create some better value addition into our lives, right? So how the recommendation system helps us to have more engagement and more interest to actually know what we really want, right? Customized recommendations, right? So how your Google app, or Google Map probably, or Google writing email system, right? So those are having a lot of intelligence these days, right? And that also helps us, and that is the underneath there is a machine learning algorithms. Those helps us to have such an experience for the user. Okay, so there's a lot to talk in this area. So I'll jump onto the types of machine learning. Okay, here we will see that how a machine learns and what are the different ways machine learns, right? And something called supervised machine learning, unsupervised machine learning, and reinforcement machine learning, right? You might have come across this term somewhere, right? Let me clarify what it is, how it differs, right? And what are the algorithms we will be talking as part of this course. Okay, I can see so many hands, but sorry guys, I cannot unmute all of you at this moment, right? But put your questions in the questions box. So I'll take your questions for sure towards the end of the discussion. Okay, so first of all, let me tell you, okay, how machine learns. What is supervised machine learning? Supervised machine learning, where we do train. There's a training mechanism where we have to supervise the way machines learns through giving some labels, right? Let's say I'm talking about. I have one example I can probably show you here. Right? Suppose I'm explaining how Apple looks to a machine. I show hundreds of images to the machine, telling that, okay, this is the image of an apple. That an apple is a label to that picture. right? So I show such 100 images, then machine understands that, okay, this is the apple, because we have now given that label, right? Given that name to the data which I'm showing to a machine, right? Then machine can actually figure out the relation or figure out the different characteristics or features of the data, like, color, maybe the shape, maybe the size, maybe the weight of the fruit, the taste of the fruit, and so on and so forth. Okay, these all features, or these all variables called independent variables, are learned by the machine, right? That relationship can be derived from these independent variables and the target variable, that is the name of the fruit, that is apple, right? And it will derive some formula, right? Where if you show new apple, right, any new object, so it will say that whether it is an apple or not an apple. So such a process is supervised by the user, right? So user is telling. So that's why it falls under supervised machine learning, right? And in unsupervised machine learning, so we don't have labels given, right? We are trying to make machine to figure out the relationship. Okay, generally the clustering problems comes under this category, where the similar uh, animals are clustered together, right, based on the similarity into the features of the data, right? So many times you will see customer segmentation, right? Or the your credit card company probably categorize the privileged customers and the normal or gold customers or platinum customers, right? So that kind of segmentation can be done, right, through something called unsupervised machine learning, right? So I'll come to I'll come to another type of machine learning, that is called reinforcement machine learning, in a while. First, let me tell you what is there inside a supervised machine learning, right? There is a regression and a classification, right? There are two types of problems which we want to deal with, right? When there's output or outcome we look for is a numerical continuous data, right? We apply regression like the linear regression, polynomial regression, multiple regression, right? So these are some of the algorithms we can have to solve such problems where there is a target variable which is the numerical outcome, that is continuous numerical data, right? And the classification is where you have a categorical outcome. So those are some of the basics before we discuss for sure, right? What is categorical, what is numerical, and different types of variables, right? But to make you clarify with a simple example, let's say, if you study hard or if you study for few hours, right? What is the outcome? What is the marks you get is what comes under regression, and what is the outcome, whether you will get admission to a particular school or not, that is the outcome. When such outcome is a categorical, we apply classification algorithms on that, right? So there are so many algorithms in the classification area as well: logistic regression, decision tree, random forest, support vector machine, naive based classifier, XGBoost, CatBoost, and so on and so forth, right? There are few maybe a dozen of algorithms, right? Few you can alter, few you can change, few you can write on your own, right? Or you can use the standard algorithm. These are fantastically doing well, right? A lot of companies implement random forest or logistic regression, support vector machine, naive based, especially in the NLP. So you would see these are some of the algorithms which are practically applied on many real world problems to solve, right? In unsupervised machine learning, when we don't give labels to the algorithm, right, we leave to the algorithm to find out that structure and identify the similarity and dissimilarity between the different data points, right? And we have algorithms for that, is something called k-means clustering and agglomerative clustering. Okay, these are the clustering algorithms, quite popularly used for many businesses. So we will see fundamentals of it, how it works, what is the maths behind these algorithms. And there is something called dimensionality reduction feature engineering, right, where we do apply principal component analysis, and we will see how this helps to basically work on some features, to transform some of the features, to reduce some of the features, or to select and extract some of the features from the data, right? That's another quite useful process of optimizing your algorithms in order to uh, you know save your algorithm, or do your make your algorithm better in terms of bias and variance, right? So I will talk about these terms in the course for sure in the detail, right? And you can see better optimized outcomes out of these algorithms, right? So let me take you through reinforcement machine learning. That's another type of machine learning which works on the with the experience. Okay, so the algorithm which works with the experience, right? And the Q learning is the algorithm we work on in this particular program, right? So this is a process where you have agent, and you have agent, and you have uh, the environment, right? Which basically environment will throw challenges. Our agent has to perform some actions, some tasks, in order to get some rewards and observations, right? So here the agent is a machine. Agent is a software component. Agent is something, right, which is in the learning process, right? So we have in the supervised machine learning, we have training data, we have input and expected output, and we train the model. But in a reinforcement learning, there is no expected output, right? It is something where we make agent to learn out of the unknown environment, right? Uncertain environment. Okay, so agent is put into the environment which is not known, and agent has to hit and try different methods and make some errors, and figure out the environment for the best rewards, what it can get out of it, right? It's a simple, if you want to understand a little bit more about this, it's a simple process where suppose you want to hit you want to get to this flag, let's say, and agent is here. So suppose if the agent takes one step ahead, right? So agent will get probably 2 marks here, or 2 points here, right? If it makes another step, maybe 1.5 or 2 points. If the agent makes a step in the opposite direction, probably it will get negative 2 or 3 points, right? So that way agent has to figure out where it is rewarded and where it is penalized, right, in order to go to a goal, right? So that is the process, right? That's where the reinforcement machine learning algorithm, right, works. And the process will have some of the terms like what agent is, what environment, action, the policy. So the idea here is to find out the best policy, okay, which can be concluded, right? And that is the best policy we want to probably figure out. To take a simple example, right, today if you think about the application of this, that's there in the in the autonomous car, or many applications around you. Maybe if you want to think about business process performance, right, today, so you can think about food delivery, right? So food delivery is happening for everyone, especially after COVID, after pandemic, right? You see that a lot of food delivery apps, or everything deliveries are happening more now compared to what it was earlier. So you can think about optimizing this, right? You can think about creating an agent which can optimize the delivery process. If it takes 30 minutes to deliver a food, and if you train your model, right, if you train your agent to deliver this in 22 minutes, that is going to be a greater impact, not only on the businesses, but it's a customer experience, right? So we can minimize the drop of time, and in turn will minimizes the fuel cost as well, right? So we can optimize such a delivery optimization mechanism. We can perform through algorithms called q learning algorithm, right? This can be used to find the optimal policy, right, where the agent can have different trials and find out the best policy which fits here, right? So this is the example which I could think about, but yes, there is a lot to talk in this particular uh, area, right? So and definitely you will explore many things out of this. Okay, so this is about types of machine learning, and let me now move on to the next topic here. What I was talking is tools and technologies, right? What is that we learn and we need to learn out of this, right? So machine learning is made simple, I would say, because of such a wonderful programming language called Python. It's a one-stop solution because it gives you a tremendous amount of powerful libraries, which I have listed on the right hand side of your screen, right? you can see, okay, NumPy, Pandas, right? The scikit-learn, SciPy, Matplotlib, Seaborn. So these are some of the libraries. Okay, you could get a sense of it in the course how we use, and even in today's demonstration part of our discussion, I would like to show you how these libraries can be leveraged to write some small basic model in your hands-on session today, right? So Python helps you. Python is such a powerful programming language, and it is a very simple one can learn. Those who do not have programming background, one can learn. The only thing is you need to commit your time and put your efforts. It's quite easy, guys. So it makes you happy and comfortable to write your code into Python, right? Such a simple and powerful programming language, and that's why this becomes much popular in the industry today, especially for machine learning and AI. Okay, so you don't have to write all the complex algorithms, that statistics from scratch. A lot of things has been already there, we can reuse, right? We need to learn programming only to reuse some of the things, right? That's why some basics concepts we need to learn, and that is covered as part of this machine learning program at Cognixia, right? So easy data extraction, effective data management, and advanced data exploration, visualization that can happen through Matplotlib, Seaborn, Plotly, and so on and so forth. There are many other visualization libraries as well. Okay, machine learning libraries, scikit-learn is the best one, powerful one. We have stats models, right? But scikit-learn is quite popular, and a lot of algorithms have been there. And moreover, we also have TensorFlow, Keras. So these are some of the libraries can be used in machine learning and deep learning concepts. Okay, deep learning packages, yeah, that's where Keras and TensorFlow I was talking. Okay, and easy deployment and easy development, right? So the process of deploying the models using Python is quite simple, right? As well as the development is simple. Compared to any other programming languages, Python takes less amount of lines of code, as well as it is quite faster and simpler, right? So this makes Python a one-stop solution for many of your work in machine learning. Okay, here is a process. Here is the different phases in machine learning, right? If you are wondering what is happening, where one can start, right? If you are, leading your organization or a particular region or area, right, or a group of people, right? If you are a manager at some company, so you should also know the whole process where this machine learning can start and end, right? So a lot of people also learn who are having a lot of experience and who are also having fresh graduates probably, right? Those people also can think about the entire process where how we train our model from a data set which is a training data set. Now that is another concept where we have a whole bunch of data, we split it into two parts, okay, or three parts basis on volume of data what you have, right? A major chunk you use for training your model, right? So once your model is trained, your model will figure out the relationship between your dependent variables and different features of the data. Okay, it will have that that complex relationship which you don't need to understand, but your model will have that. Then you can evaluate your model, how well your model is doing, right? That you can check using some small chunk of the original data set, that is your testing data or evaluation data, and see how well your model is doing. If you find it is doing well, then there is a chance that it will do well for unknown data as well. Then you can put into a production. So there is a whole process which is a little bit of a recursive process, because we have to revisit your business objective again and again, right, after training your model by doing a hyperparameter tuning, understanding how much it is it is achieving your goal or objective what is defined, and then if it is accepted by the business, right, then it is a time to deploy, right? So that's the whole process we have, right? In the process, the very first thing is do a feature analysis or pre-processing of your data. First you have to extract the data, collect the data from different sources, understand what is important, what is not important, right? So process that data, then process with some bit of a statistical tools, and do some feature engineering and encode the data using, let's say, one hot encoding or label encoding, and then it's a time to do modeling, right? So choose some of the model, and then you can perhaps evaluate and check how well you are doing, and then you can conclude on this, right? So that's how it is. Then the simple business problem, I just thought of highlighting you how one line statement can be a business problem. Now it is your object, your target or your goal is to meet this objective, right? So how you can improve the sales of a retail store, let's say. Then let's say Walmart or a Big Bazaar is, or a B-Mart is coming to you, and they want to improve their sales, right? So in this process for the retail, there is something called there are a few algorithms like a priori algorithm, association rules. You can figure out the retail business, how it works. You can find out the data which is there, the historical data with the business, right? You can do analyze the data, you do that data mining, and the finding the patterns, finding the customer's behavior, right? And you formulate some of the rules which can be used using association rules and market basket analysis, right? We have a very powerful algorithm called a priori algorithm. We can use that in order to bring that relationship between the various invoices what has been there with the company, right? Now you can tell some rules that, okay, follow this to better manage your inventory, better manage your discounts, better manage your customers experiences and recommendations. So that in turn improves the sales for sure, right? So that is how some of the cases you could apply if you are from the background where you want to do something in the in the retail industry. Okay, so there are so many in the recommendation also in this course. So we will be also having recommendation engine. We will be writing some code to do a movie recommendation, right? So Netflix has more than 75% recommendations what you do if you are a movie watcher, right? So recommendations are made through machine learning, that is unsupervised machine learning, right? So you also see how your friends is getting tagged. Okay, this is also another type of unsupervised machine learning. You see Alexa, right? Conversion from voice to text, text to voice, and processing, right? That's also part of AI, means machine learning, right? So the filtering of emails, whether it's a spam email or a legitimate email, so that kind of filtration, I would say it's a classification problem, where you want to your idea is to classify your emails, whether it is a spam or not a spam or a legitimate email, right? So that kind of a technique is also done through machine learning algorithm. That's a classification problem under supervised machine learning, right? So we can also write some of the algorithms practically to see how you can classify your databases on some characteristics of the data, right? So it's a binary classification. If there are two classes we want to talk about, then we go for binary classification. Okay, so this is what I wanted to discuss in the theory part. I would like to take you through a little bit on the basics again, right? So this slide I want you to just look at once, then I will take one problem statement, right? So classification problem. Okay, by using a built-in data set. I don't want to complicate things in this short session, but yes, definitely you will understand how you can actually develop a simple model using classification algorithm, maybe a decision tree or random forest classifier, right? And we will do some predictions for the given data set, right? So that is the next thing. Before this, I would also like to introduce you, right, the tool which we will be using, right? In the training, we will be doing this thoroughly, the complete installation part of it, right? And then a lot of hands-on and shortcuts, short keys you will be learning, right? So for now, I will help you understand is Anaconda Navigator, right? It's a suite of softwares. It's a very powerful and very interesting tool, a very useful tool for all the machine learning enthusiasts, data scientists, and AI engineers, right? So they generally go for Jupyter Notebook or Jupyter Lab. But you, if you have already past experience with PyCharm, if you have working knowledge on Python, so you can very well use PyCharm or Spider. These are another couple of IDEs, or you can think about any other IDE like Sublime or Atom or anything, right? So there is no restriction as such. It's just a matter of installing few packages if you need, right? Otherwise, people generally go with this Anaconda Navigator. It's a free open software which you can install. That's a community edition you can install, and you can use one of these IDs, right? I'll go for Jupyter Lab. Okay, if you go here, I haven't opened. I will click and open this. So you will see this is the Jupyter Lab we can use. I can probably use and create a notebook which you can probably write your code. So if you don't understand completely at this moment, that's okay. So this is something which we do in our training when we start. Right on day one, we will definitely install these tools and learn more about what is this tool is all about, how to write your first program, and right from the basics is covered. But now I'm not going to go with the basics of programming, right? But I want to deep dive and show you something which we want to do. Okay, I will import pandas. I'll import NumPy as NP. I'll import matplotlib.pyplot as PLT. I import Cbon as SNS. So these are some of the libraries I want to use. Okay, so just a minute, I want to ignore these warnings. Oh, okay, there are some warnings which we could ignore, so I'm just ignoring them. Now, I have one data. Okay, I have, just to save your time, I can get it from the UCI library, right? That's a repository. That's a very good repository where you will find some best well-known data sets. Many of them are pre-processed data sets which you can use and work with this data. Okay, or you can get it from the scikit-learn, right? sklearn dot dot datasets import iris data. Okay, so you could actually get any of this or load iris maybe. Okay, yeah, load iris or load boston or some of these built-in data sets are available. So anyway, I'm not going to use this, so I can comment it, right? But I will be using this from this particular place, right? Both of them have the same data. Okay, no difference. So let me introduce you with iris flowers, what it is, and why we are doing this with this particular data set. Let me tell you. Okay, this is the type of flowers you find, right? These all different types of flowers looks very similar, right? Because they belongs to similar category, but they have different species, right? For example, this one falls under versicolor, and this one falls under setosa, and this one is under virginica. So these are three categories of flowers. They look very similar. Okay, so now the objective here is to train your model based on some features of this data, right? Characteristics like there are sepals and petals. So the dimensions varies here if you look at this data carefully, right? So now if I train our model with the sepal length and sepal width, length and petal width of this particular flowers, right? Whatever historical data I have, so I can see the model is now getting trained with the dimensions, and then it will figure out the relation that, okay, this is the versicolor having this kind of characteristics, right? And this is a virginica, this is a setosa. So these are the three classes you see. That is your multi-class classification problem, right? There are three classes. So you could work on a very similar concept to, let's say, handwritten digit classification problem, right? Or you can think about a topic classification, news identification, news classification, right? So you don't have to be manually looking at different news, but you can classify news basis on the sentiment, maybe basis on the category, right? So customer segmentation could be another example, right? So I'm taking a simple iris data set, but the same concept is used for customer churn management, right? Customer segmentation, topic classification, handwritten digit classification, right? And so on and so forth, right? So that is what we can do. Let me first get a data frame Okay, let's say I will read it from the, I can use CSV itself, but I can read actually from this URL. I can do that. Okay, names equal to, I have names. So, I can see this data set got loaded. So I'll save it into, let's say, Iris. Okay, and iris.head. I can just see first 5 records just to for our eyes that, okay, these are 4 features, and this is the target variable what we have. Okay, so we can do a little bit of analysis, or maybe you can just do check how this data looks like. There's a group by function which can group basis on some value we want to give. So basis on target, let's say I want to see how many how many groups or how many values are given, right? This is a perfectly balanced data set. We have Setosa 50 records, versicolor 50, and virginica 50. There is no missing data. Okay, there is no outliers as such to really deal with. There is no much of a pre-processing we need, right? So that's why we are not doing so much here. That's why I chose that data. So we also can see some of the basic statistical analysis. Okay, Iris. So you see that this is a box plot. So don't whoever don't know about this, no worries. You will definitely learn this in detail, right? So a little bit of stats, and then a basic stats, and then how this statistical summary helps you to understand data a little better, right? So that's where the data pre-processing comes in. So for that matter, you can actually do do check the sorry, histogram, hist. Okay, so you can also check the histogram. Just to get rid of this text, I can write plt.show. Okay, so you can see the only the plot, right? So you can see different plots. In fact, you can see pair plot as well. You want to find out the relation between all these different variables, right? So there are 4 categories, and how every one is related to each other. Okay, that kind of a correlation you can find it, right? Probably I can do with one hue of target here, so that you'll get little more colorful stuff. Let me see if it works. Yeah, it works, right? So this is again a part of pre-processing and understanding your data, right? So we may not be go deeper into this at this moment, but yes, this is where you will be very much comfortable when you go through the course, right? So iris.ilog, again, this is a function which you can use. I want to get up to 4th column, not including 4th. That means 0, 1, 2, 3. That means first 4 columns I'm taking. So that is my features, and I store it into capital X, and small x is the target, right? Where I have iris.ilog, and all the rows and only the 4th column and values will convert this into a numpy array. Okay, so that's how my x and y you got from scikit-learn, right? Model selection, I import train test split, right? And then once I have this function, right, this is an interesting function, but you can do manually split your data, right? That is just a matter of splitting your data with some random seed. So for example, suppose I have this particular, I just don't have to remember the syntax, right? Such a simple programming, guys. So you just take a help page here, you go here, and then copy the syntax. You don't have to change anything as such. And even x and y, I use the same way, right? So it is simply, it will split your data into 33% test size, or you can go for 20% test size, where 80% your training data, right? Usually our training data should be little higher. So we can have some random seed of 12, right? So here, if you understand, now you got your text data, right? If you see your X or your iris dot shape, okay, you will see this. So 150 by 50, right? There are 150 by 5. There are 5 columns and 150 rows. Whereas, X train dot shape, if you see, there are 4 columns. Remember, there are 4 features. X means it's a features, and Y means it's a target. There are 4 features and 120 records. The reason is I took 80% of 150, and that is 120 records, right? This much is the data I use for training. So this is your question, and why train? I have answer as well, right? So answer has 120 records, right? There is single column, right? So now you have question and answer, so that you can learn from both of this, X train and Y train. Okay, now as I have introduced you with so many algorithms here, right? You can see logistic regression, right? Decision tree, random forest, classifier, support vector. So I can probably demonstrate you few of them, right, from sklearn dot ensemble, or I'll go with the decision tree first. Tree import decision tree from sklearn dot ensemble, right? Again, the what is ansible, what is bagging and boosting. So those things are covered in detail. Okay, so for example here, random forest classifier. Okay, from sklearn dot svm import support vector machine svc, right? Or you may go for logistic regression, you may go for naive based classifier. Okay, naive based import just import Gaussian NB. Okay, these are 3 or 4 algorithms we can try. You can think about more algorithms, but I don't want to complicate things at this moment. But I don't want to keep so simple as well. So what I will do is sklearn dot model selection dot model selection import. K-fold. K-fold is the how we can use for model evaluation technique, right? It's a K-fold cross validation we can use, and we have a score. For the same, we can check this couple of functions we can import from the model selection submodule in scikit-learn, right? Then suppose I create few models here. So I know this is going to be little complex those who don't have much programming background, but as I said, so there's a lot of basic foundational knowledge we cover in the course. Right here I'm just demonstrating you how we write each and every algorithm thoroughly by understanding and doing it hands-on, not just theory. Okay, so models dot oops, sorry dots append. I can append a list or another tuple maybe. Okay, this is your decision tree. I just name it and I will create an object for this here. Okay, so I keep this whole thing and I'll just keep on adding this. This is for next is random forest. This is for svc or svm, and here it is for naive base nb. Okay, so here it will be random forest. Here it will be svc, and here it will be Gaussian NB. Right now, I'm not considering the optimizing of the parameters. I'm not doing any hyperparameter tuning at this moment. Okay, just to make it simple for now, right? So I keep your basic models, and then I can probably run for each of the models. Okay, name and the model in models. Okay, the basic for loop, guys. So this is again covered with a lot of hands-on in Python basic foundational knowledge, right? So I will use kfold, and I can use kfold function to split data into 10 parts, let's say, and with some random seed of, let's say, 7 or something, anything. Okay, then I will use cross validation results to evaluate who is doing what, how they are doing. So cross validation score, I will get a model, how it is doing, and I give the data, the training data, and training data contains x and y. Okay, and cv equal to k fold. I will use k fold. Okay, and you can have scoring equal to accuracy, right? Just to get accuracy of this, right? So then result, I will store all these results into a list here, right? And then results or result, I will go for results. Okay, results dot append, I will go for each of these results, cv result, right? I'll keep on appending, right? And then I will print there's a formatted string. I hope you know the syntax. This is a little newer than the older version of Python after 3.6. So here I can have name. Okay, in the round bracket I can have let's say round and cv result dot average. Okay, that's how the average results we considered after applying a tenfold cross validation. Okay, so this is where we get mean, and I want to round it up to 4 digit. Right? So let me check if it works. Great, it worked for all these different algorithms. And you can see that. Yeah, excuse me. So you see that decision tree is 94% accurate. This is doing a predictions, and random forest is 93%. Then support vector machine is doing fantastic here, better than any other algorithm, right? So that's how you can actually perhaps you can evaluate your model. You can probably do find some scores through different metrics from scikit-learn.metric, where you can have accuracy score. We have something called confusion matrix. We have something called classification report. So all these things are covered. So idea is not to overwhelm with a lot of information or load with a lot of information to you guys today, right? But I'm just trying to give you the glimpse of the process we do follow in the learning process, especially in the training, right? So that's how we do develop the models, right? But this is more of a very simple data set. We can go with the complex practical examples and data sets. So that will make you get more confident on when you talk about the machine learning, in the interviews or anywhere, right? So this makes your concepts clear, guys, right? And that is something very important for everyone to really talk up to the course, right? So course should not just give you the the certificate, but what we believe is you get that practical hands-on exercise, right, which we will be doing. Not only the classification problems, regression problem, but we have whole set of concepts to be discussed right from the foundational, right? Let me reiterate again. Those who are thinking that programming is required, yes, it is required. There is no shortcut, but trust me, this is going to be a fun learning Python, right, with a very simple approach. We will have first three sessions only for Python. So we will be very comfortable with Python by that time, with some more advanced things like lambda functions and list comprehension, dictionary comprehension, how we use them, because this is something we will use going forward in the exploratory data analysis and machine learning data pre-processing, right? So that's why we do spend three sessions, including NumPy, Pandas, and some of the data wrangling algorithms, uh, techniques in Python, which we do with the help of these libraries. Okay, and that makes you comfortable going forward when we really deep dive into machine learning details about every algorithm we cover with different examples. And then we also have dimensionality reduction, factor analysis, PCA, LDA, right, in unsupervised machine learning, then clustering, agglomerative and k-means clustering. Then some of the performance evaluation metrics, that's most important, because that's where we do evaluate your model, right? A lot of interviewer really check your skills, how deep you are into machine learning. That is identified through this particular part of the discussion here, right? So you should be comfortable with the cross validation, k-fold cross validation, bagging, boosting, bias, variance, right, trade-off. Then how you can actually evaluate a model with the class confusion matrix, what is type 1 error, type 2 error. So those are some of the questions you will get answered in this discussion, in this particular section, right? So recommendation engine, we will work with recommendations, we will work with association, a priori algorithm, market basket analysis. And those who are interested in time series, there is one session for time series as well, right? And the reinforcement machine learning, and the last we will end up with the deep learning, the principle behind deep learning, how deep learning works, and how this will help you leverage your most of the learnings whatever you have done. What is the difference, what exactly extra thing you can bring for your business, right, and optimize your businesses through this learnings. Okay, so this is the agenda we have as a whole for this entire training program, for close to a couple of months of weekend time what we spend, right? And this makes you much comfortable going forward. So I hope you understand the whole idea behind. And let me end now, we are almost done. Okay, there's a simple case study, right? Maybe I'll take another couple of minutes, not much time, right? So for discussing about this, something called predicts cloud, for which is there for GE, right? So GE is and I hope everyone knows GE. GE is General Electric company, everyone knows, such a huge company, and they are into wind turbines, and they have turbines located at the field, different locations, and those turbines are quite very useful, right? Very powerful to generate energy, right? So BLP is another company in the power renewable energy, right? So this is another company. Also, they had applied machine learning and predictive analytics on their monitoring techniques, and how they have transformed the way businesses were working for last 20 years, and now for last 5 years, there's a tremendous change, right? They could manage their downtimes most efficiently, right? Especially such a turbines, if they go down in the peak season, there's a huge revenue it impacts directly on, right? So that's how machine learning can help you have that intelligent predictions, right? Predicts is such a cloud on the Google, on the GE, it might be on AWS or Azure, right? So I don't know about that, but the Predix cloud gathers the data from different turbines, right? And similarly, this Predix cloud was leveraged for their another business line where they work on the turbojet engines, right? GE also manufactures turbojet engines, the engine placed on the airplane, right? So definitely they don't directly create aeroplanes, but the companies like Boeing or Airbus, they create the aeroplanes, and they buy engines from GE like company, or Honeywell or GE, right? So these are some of the companies, right? So, and then Boeing or Airbus, they manufacture the aircraft and they sell to the carriers like Indigo or Jet Airways or Vistara or anything, right? Any other carrier. So, one of the case, why I pulled this slide here is one of their Indigo flight. Indigo is a customer to the aircraft manufacturer, but ultimately their engine is from GE, right? And their hub is Kolkata, and they got their flights parked there when they are not flying, right? So, a couple of engineers from GE landed on one day, and they told officers that, okay, this particular aircraft might go down for in another a week or so, right? So, and then they fixed the issues, right? They found the glitch before it actually happened, and they went off and they guaranteed that next 6 months nothing will happen, and that was actually happened, right? And that's how the Indigo got really happy with such kind of service, where it is more than the revenue loss if they got a downtime of a flight, but it is more of a safety and customers delight, right? So how they got their customers happy by fixing such a problem even before it actually happens, right? So that's what machine learning can do. That's how machine learning can have the data to analyze, to learn, and make some predictions in future, right? So that is already there, right, in many businesses, and still a lot of businesses are looking for right talent, right? And we, this group is, I really appreciate that you guys have interest and want to build your career. So this is the right time to board the bus of AI, where we see a tremendous growth for next decade or so, right? So this is what I had, guys, today in the discussion. I hope I have given you some information which definitely will help you to enhance your skills, right? That's what my objective was for this 1 hour of time, what you are putting as well as what I'm putting here. So thank you very much. Thanks for your time, and thank you for joining the session and listening to me. I hope I have created some value addition, right? And please keep studying and keep in touch with the subject, and definitely this will help many of you. Okay, thanks again, and all the best. Bye bye. Take care.